It all started with something incredible. Google created a powerful quantum computer, their most advanced one yet. This machine could solve problems that even the world's strongest supercomputers couldn't touch. But some scientists now believe that it might not be solving these problems on its own. They think it could be getting help from somewhere else, maybe even another universe. Some physicists have noticed that the quantum computer's results are incredibly fast and accurate, so much so that they might not be coming from our universe. The idea is that these machines might be using other dimensions to do their calculations. It sounds like something out of a science fiction movie, but it's actually based on real science from quantum physics. And here's the most surprising part. If this theory is true, then we may have already opened a door to the multiverse without even knowing it. To understand this better, we need to know what a quantum computer really is. Today, we use regular computers for everything, from booking trips to ordering food or finding matches on dating apps. These devices are now a part of our everyday life. But even with all this technology, something even stranger and more powerful is starting to emerge. Quantum computers. Recently, these machines were discussed on a popular podcast, the Joe Rogan Experience. This podcast often dives into deep and unusual topics like black holes or ancient civilizations. On one episode, they talked about Google's quantum computer and the idea that it might be able to interact with different universes. That episode sparked a lot of interest online. But what exactly makes quantum computers so different from normal ones? Traditional computers work with binary code, just ones and zeros. Quantum computers, on the other hand, use something called qubits, which can be both 1 and 0 at the same time, thanks to a concept called superposition. Imagine flipping a coin and it landing on both heads and tails at once. That's the kind of weird logic quantum computers use. This allows them to look at many possibilities all at once. Another strange idea from quantum physics is called entanglement. It means two particles can be so closely linked that if one changes, the other changes instantly, even if they are far apart. Even Einstein called it spooky action at a distance. In 2019, Google's quantum computer, named Sycamore, did something amazing. It completed a task in 200 seconds that would take the best supercomputer about 10,000 years to finish. This moment was called quantum supremacy, the point where quantum computers officially became more powerful than classical ones. Since then, big companies and scientists have been racing to improve these machines. The main challenges are making them stable and accurate. Qubits are very sensitive and can lose their state easily. Even a tiny change in temperature or movement can throw them off. To prevent this, engineers use very cold and quiet environments to keep the systems running properly. We're not at the point where we have quantum computers in our homes yet, but researchers believe that one day, these machines will solve real-world problems, things too complex for today's computers. Now, here's where it gets even more interesting. Some scientists think quantum computers might be able to access other universes. This theory is based on the same strange rules of quantum physics. If particles can exist in multiple states at the same time, maybe entire universes can too. Each universe could show a different version of events. This idea came up during Joe Rogan's podcast. The guest speaker, a physicist, explained that Sycamore might already be showing signs of something strange. The machine sometimes produces unexpected data, patterns that don't match what we would expect based on known physics. Some believe these patterns could be signs of interaction with another universe. Imagine if quantum computers could act like radios, picking up signals from other dimensions. Some scientists think that under the right conditions, the machine might produce data that looks like static at first, but then shows a repeating pattern. If that happens, it might mean we are receiving information from somewhere else, maybe even another version of our world. Rogan asked a powerful question. If the signals are real, who or what is sending them? Could there be another version of Earth out there? Another version of ourselves? This kind of communication could lead to major breakthroughs in science, health, and technology. If another universe already found a cure for a disease, we might be able to learn from it. If energy problems were solved elsewhere, we could bring those solutions here. But of course, this also brings up big risks. What if the other universe doesn't want contact? What if opening this door causes problems in both worlds? Even if the beings in another universe aren't dangerous, just connecting with them could cause chaos. The physicist warned that we don't yet have the tools to prove if we're really talking to other universes. All we can do is look for strange patterns and try to understand them. Still, the fact that scientists are even thinking about these things shows how much our understanding is changing. This whole topic connects to one of the biggest mysteries in science. We can describe and predict how quantum systems behave, but we don't know why they do it. The rules of quantum physics work, but we don't fully understand the reason behind them. That's why some of these theories seem both exciting and scary. Interestingly, ideas about multiple realities aren't new. Ancient beliefs in Hinduism, Native American spirituality, and Western mysticism have all spoken of many layers of existence. What's new is that science might now have the tools to study these ideas in a testable, logical way. Joe Rogan's podcast circled back to the main question. What are quantum computers really for? Right now, we know they're fast and powerful, but we don't fully know what they're capable of. Maybe they'll help us understand the universe in a completely new way, not just through space, but through reality itself. The true power of Sycamore might not just be in how fast it calculates, but in what it might reveal. One day, it could act like a translator between different realities, turning strange quantum data into something we can understand. If this happens, the benefits could be massive. We could see new medicines, smarter AI, and better technology, borrowed from other worlds. Scientists are already thinking about ideas like interdimensional medicine, where we could learn treatments from versions of Earth that made different choices. Quantum computing is still in its early days, but its potential is huge. If it lives up to expectations, it could completely change how we understand health, science, and the universe itself. Diseases like cancer or Alzheimer's might already be cured in other realities. If we find a way to connect with those places, we could bring those solutions here. What seems like science fiction today might become tomorrow's reality. Just like electricity, space travel, and the internet once seemed impossible, the ideas we're exploring now could shape the future of humanity in ways we can't yet imagine. Quantum computing, artificial intelligence, and the concept of the multiverse form the backbone of a deeply layered conversation on the Joe Rogan Experience, one that stretched from scientific possibility to ethical uncertainty and philosophical reckoning. What began as a speculative discussion about future technology quickly became a meditation on humanity's readiness to wield such power, and the potential consequences of rushing ahead without understanding the full scope of what we're unlocking. One of the earliest points raised involved the profound medical advancements that quantum computing might make possible. If we gain access to medical knowledge that could eradicate disease, regenerate tissue, or even extend life, the next question becomes one of access. Should this knowledge be shared unconditionally with the world, or would governments classify it in the name of national security? The guest emphasized that without a strong global framework in place, these breakthroughs could deepen the divide between those who benefit and those who remain excluded. Environmental science is another field poised to be transformed. Climate change, with all its intricate and interrelated factors, from carbon emissions to ecosystem shifts, could be tackled more effectively if we had machines capable of processing data on a scale and speed that classical computers simply can't match. Quantum systems might even allow us to borrow solutions from other timelines, assuming such knowledge exists and can be interpreted. Perhaps, in some version of reality, humanity abandoned fossil fuels decades ago and learned to harness energy from floating solar grids in the atmosphere. If we can access those models, it could revolutionize how we approach sustainability and conservation here and now. Artificial intelligence, naturally, entered the discussion. AI thrives on data, and quantum computing would supercharge its ability to analyze, learn, and evolve. The real twist came when the guest suggested that, given access to multiversal knowledge, AI might develop new ways of thinking, intuitive, emotional, or even alien. If it gains insight from countless versions of reality, it may form a moral compass entirely different from our own. That possibility raised a pressing concern. Would such AI remain under human control, or would it pursue goals of its own? This isn't just about smarter machines. It's about creating entities that could outthink us across multiple dimensions. The conversation turned to physics and the elusive theory of everything. Scientists have long sought a unified explanation for all the fundamental forces of nature. So far, no one's cracked it. But the guest speculated that with quantum systems able to pull data from alternate universes, we might discover laws of physics that operate completely differently elsewhere. Maybe time flows backwards in some dimensions. Maybe gravity behaves in ways we can't even imagine. Unlocking those secrets could completely rewrite our understanding of space, time, and matter. They also floated the idea that intelligent life from other dimensions may already be trying to contact us, not with spaceships or radio signals, but with interdimensional patterns we've mistaken for noise. The eerie thought lingered. What if we've already received messages but lacked the technology, or imagination, to recognize them? The challenge, Rogan's guest pointed out, is distinguishing between a real signal from another universe and a meaningless glitch generated by a quantum computer. That would require not only smarter tech, but smarter scientists, people trained to look beyond what we expect to find. As the implications deepened, so did the psychological and cultural stakes. Imagine living in a world where alternate realities are proven and observable. For some, this might unlock new levels of creativity, exploration, and hope. For others, it could trigger identity crises, religious upheaval, and political chaos. If we're just one thread in a limitless tapestry of realities, what does that say about the choices we make? Do we still matter? Or do our actions echo across infinite timelines? The dangers of meddling with the multiverse were also explored. While the prospect of breakthroughs from other timelines sounds exciting, it brings terrifying possibilities. What if we accidentally damage another world's balance? What if chaos bleeds into our own? The guest raised a critical question. Do we have the emotional and ethical maturity to explore the multiverse responsibly? Without clear codes of conduct and global consensus, the risks might outweigh the rewards. Quantum technology also has enormous geopolitical implications. Governments would almost certainly seek control over it, especially if it means gaining access to advanced technologies, military strategies, or political tactics from alternate Earths. Why invest decades in research when you could borrow solutions from another timeline? But that leads to unsettling power imbalances. If one nation weaponizes the multiverse, the resulting dominance could destabilize the entire world. And if alternate timelines can influence one another, warfare might spread beyond our reality, with consequences we can't predict or contain. The conversation then veered into time itself. Since quantum particles can exist in multiple states, quantum systems might allow us to view different points in time, past and future alike. That opens the door to predicting natural disasters, solving cold cases, or preventing tragedies. But it also creates a moral minefield. If people act differently based on what they see in the future, they might change that future entirely, triggering paradoxes. It's a butterfly effect at the quantum level. More chaotic and more dangerous than we're used to dealing with. Rogan kept returning to the core idea that curiosity, while a powerful driver of progress, can also be dangerous. Are we truly ready to face what we might discover? The guest argued that wisdom might lie in restraint. Maybe the more important question isn't what quantum computing can do, but whether we can handle the truths it reveals. If those truths include infinite versions of ourselves, alternate histories, or futures we're not meant to see, then curiosity becomes a cosmic force, not just an intellectual one. They touched on how these revelations could ignite a new wave of artistic and cultural expression. Writers, filmmakers, and artists might find endless inspiration in the multiverse. But just as the internet brought both enlightenment and conspiracy theories, quantum tech could unleash misinformation on a whole new scale. People might fabricate proof from other dimensions to justify actions here. Critical thinking, scientific literacy, and ethical guidance will become more important than ever. Toward the end, the conversation circled back to some of science's deepest mysteries, like dark matter and dark energy, forces that make up most of the universe but remain mostly unknown. Quantum systems might finally crack those codes. The origin of life itself could be understood by simulating countless chemical scenarios across realities. We might pinpoint the precise conditions that lead to life, revolutionizing not only medicine but our search for habitable planets. Then came the spiritual turn. Many religious traditions speak of higher planes or alternate realms. If quantum computing validates those ideas scientifically, it could blur the line between science and spirituality. This might bring harmony between the two, or it could spark profound controversy. Some might see their faiths enriched by quantum insights. Others might feel their sacred beliefs are being co-opted by science. A new wave of belief systems could emerge, combining ancient wisdom with quantum mechanics, meditation informed by entanglement, sermons quoting scripture and physics alike. In the end, both Rogan and his guest emphasized humility. We're still in the early days of quantum computing, and already it's forcing us to question the very structure of reality. The road ahead will be filled with breakthroughs and blunders, promise and peril. But if we engage with these mysteries thoughtfully, if we build frameworks that match our technology with wisdom, we may just be able to navigate the multiverse, not recklessly but responsibly. Because while the cosmos may be infinite and strange, how we choose to interact with it remains entirely in our hands.